Welcome. Today we're diving into a fascinating topic: how silicon could dramatically increase energy density in batteries. Energy density is a key factor in determining how long our devices last and how far electric vehicles can travel on a single charge. As our world becomes more reliant on portable electronics and electric vehicles, the demand for better batteries is skyrocketing. But what exactly is energy density, and why does it matter so much? In this video, we'll explore the science behind energy density, the limitations of current battery technology, and how silicon might be the game changer we've been waiting for. Most of today's batteries, especially those in smartphones and electric vehicles, use graphite as the main material in their anodes. Graphite has been the industry standard for years because it's stable and reliable. However, it has its limitations, particularly when it comes to how much energy it can store. As we push the boundaries of what our devices can do, we're starting to see the cracks in graphite's capabilities. This is where the search for better materials begins, and silicon quickly comes into focus as a promising alternative. Energy density isn't just a technical term, it's what determines how long your phone lasts between charges or how far your electric car can go. Higher energy density means more power packed into the same space, leading to lighter, longer-lasting batteries. This is crucial for everything from portable electronics to renewable energy storage. As our dependence on these technologies grows, so does the need for batteries that can keep up. That's why scientists and engineers are racing to find ways to boost energy density, and silicon is at the heart of these efforts. Silicon has emerged as a superstar in the quest for higher energy density. Compared to graphite, silicon can theoretically store up to 10 times more lithium ions. This means batteries with silicon anodes could last much longer or be much smaller for the same amount of energy. The potential is huge, and researchers around the world are working hard to make silicon-based batteries a reality. But as with any breakthrough, there are challenges to overcome before silicon can replace graphite in everyday devices. Secret to silicon's impressive energy storage lies in its atomic structure. Silicon can absorb and hold many more lithium ions than graphite, which directly translates to higher energy density. When a battery charges, lithium ions move into the anode material. With silicon, there's simply more room for these ions, allowing the battery to store more energy. This fundamental property is why silicon is such an exciting material for next-generation batteries. Despite its promise, silicon isn't a perfect solution, at least not yet. One major challenge is that silicon expands dramatically as it absorbs lithium ions during charging. This expansion can cause the material to crack and degrade over time, reducing the battery's lifespan. Researchers are actively working on ways to address this issue, such as developing new forms of silicon or combining it with other materials to improve durability. Overcome silicon's expansion problem, scientists are turning to nanotechnology. By engineering silicon at the nanoscale, they can create structures that better withstand the stress of expansion and contraction. Nanostructured silicon anodes are showing great promise in laboratory tests, offering improved performance and longer lifespans. This approach could be the key to unlocking silicon's full potential in commercial batteries. Another promising strategy is to blend silicon with graphite in the anode. This hybrid approach takes advantage of silicon's high energy density while maintaining the stability of graphite. Many next-generation batteries already use small amounts of silicon to boost performance without sacrificing reliability. As research progresses, we can expect to see even higher silicon content in commercial batteries. Automotive industry is especially excited about silicon anodes. Higher energy density means electric vehicles can travel farther on a single charge, making them more practical for everyday use. This could help accelerate the shift away from gasoline-powered cars and reduce our carbon footprint. With silicon-based batteries, the dream of affordable, long-range electric vehicles is closer than ever. It's not just cars that stand to benefit. Smartphones, laptops, and other portable devices could see significant improvements in battery life and performance thanks to silicon anodes. Imagine a phone that lasts days on a single charge or a laptop that can power through long flights without needing an outlet. Silicon could make these scenarios a reality, transforming the way we use our devices. Silicon-based batteries could also play a crucial role in renewable energy storage. Solar and wind power are intermittent, so storing excess energy efficiently is essential. With higher energy density, silicon batteries can store more power in less space, making renewable energy systems more practical and reliable. This could help speed up the transition to a cleaner, greener energy grid. While the potential is clear, manufacturing silicon anodes at scale presents its own set of challenges. Producing nanostructured silicon is complex and can be expensive. Researchers and companies are working to develop cost-effective methods for large-scale production, which will be essential for widespread adoption. Overcoming these hurdles will be key to bringing silicon batteries to market. Switching to silicon-based batteries could have environmental benefits, but it's important to consider the full life cycle. Silicon is abundant and non-toxic, but mining and processing still have environmental impacts. Researchers are exploring ways to minimize these effects, such as using recycled materials and cleaner production techniques. Responsible innovation will ensure that silicon batteries are as green as possible. In recent years, there have been exciting breakthroughs in silicon battery technology. New coatings, advanced nanostructures, and innovative manufacturing methods are helping to address the challenges of silicon anodes. Some startups and major companies are already producing prototype batteries with impressive performance. These advances are bringing us closer to seeing silicon batteries in everyday products. But when can we expect to see silicon batteries in our devices and vehicles? While some products with silicon-blended anodes are already on the market, fully silicon-based batteries are still a few years away from mass adoption. Continued research, investment, and manufacturing improvements will determine how quickly this technology becomes mainstream. The future looks bright, but patience is still required. Startups are playing a vital role in advancing silicon battery technology. These adult companies are experimenting with new materials, designs, and manufacturing processes. By pushing the boundaries of what's possible, startups are helping to accelerate innovation and bring new solutions to market faster. Their work complements the efforts of larger companies and academic researchers. Major technology companies are also investing heavily in silicon battery research. Their resources and expertise enable large-scale experiments and rapid prototyping. By partnering with startups and universities, these companies are helping to bridge the gap between laboratory breakthroughs and commercial products. Their involvement is a strong signal that silicon batteries are on the horizon. Universities and research institutions are at the forefront of silicon battery innovation. Their fundamental research is uncovering new ways to improve silicon anodes and solve technical challenges. Academic collaborations often lead to groundbreaking discoveries that pave the way for commercial applications. The synergy between academia and industry is crucial for advancing this technology. Consumers are eager for batteries that last longer and charge faster. As awareness of silicon battery technology grows, so do expectations. People want devices and vehicles that are more reliable and convenient. Meeting these expectations will require continued innovation and communication from manufacturers about what's possible and when. One important factor in the adoption of silicon batteries is cost. While silicon itself is abundant, the processes needed to make high-performance anodes can be expensive. As manufacturing techniques improve and economies of scale kick in, costs are expected to come down. Affordable silicon batteries will make the technology accessible to more people and industries. Safety is always a top priority with new battery technologies. Silicon anodes must be carefully engineered to prevent overheating, short circuits, or other hazards. Ongoing research is focused on making silicon batteries as safe as, or even safer than current lithium-ion batteries. With the right safeguards, silicon batteries could set new standards for safety and reliability. Countries around the world are racing to lead in battery innovation. The development of silicon-based batteries is a global effort, with major investments in research and manufacturing. This competition is driving rapid progress and could determine which nations dominate the future of energy storage technology. Silicon batteries could help achieve global sustainability goals by enabling cleaner transportation and more efficient energy storage. Their higher energy density means fewer resources are needed for the same amount of power, reducing waste and environmental impact. As the world moves toward a greener future, silicon batteries could play a pivotal role. The story of silicon batteries is still being written. Researchers are exploring new materials, designs, and manufacturing techniques that could further boost energy density and performance. From flexible batteries to ultra-fast charging, the possibilities are exciting. The next big breakthrough could be just around the corner. As silicon batteries become more common, we can expect a revolution in consumer electronics. Devices will become lighter, thinner, and more powerful, with longer battery life and faster charging. This will open up new possibilities for innovation in smartphones, wearables, and other gadgets, making technology even more integrated into our daily lives. The aviation industry is also watching silicon battery developments closely. Higher energy density could make electric planes more viable, reducing emissions and noise pollution. While still in the early stages, the potential for silicon batteries to transform air travel is significant, paving the way for cleaner, quieter skies. Large-scale energy storage is essential for balancing supply and demand on the power grid. Silicon batteries with their high energy density could make grid-scale storage more efficient and cost-effective. This would support the integration of renewable energy sources and help ensure a stable, reliable power supply. As with any technology, end-of-life management is important. Silicon batteries will need effective recycling systems to recover valuable materials and minimize waste. Researchers are already looking at ways to design batteries for easier recycling, ensuring that the benefits of silicon batteries extend throughout their lifecycle. Government policies and regulations will play a key role in the adoption of silicon batteries. Support for research, incentives for clean energy, and standards for safety and recycling will all influence how quickly this technology spreads. Collaboration between industry and policymakers will be essential for success. Summary: silicon has the potential to dramatically increase battery energy density, transforming everything from smartphones to electric vehicles and renewable energy systems. While challenges remain, ongoing research and innovation are bringing us closer to a future powered by advanced silicon batteries. The journey is just beginning and the possibilities are truly exciting. Stay tuned as we watch this technology evolve and reshape our world.